Okay, continuing on with the review, we're on problem number 9. The directions still say to use elimination. Because my directions say to use elimination, I can't use substitution, even though this problem is set up nicely for substitution. So I need to set it up for elimination. That means I need to get my x's on the same side as the y's. So I'm going to subtract 1/2 y to get x minus 1/2 y equals -4. And here, my x's and y's are on the same side, but they're in the opposite order. So I don't need to add or subtract anything, I just need to switch it around. So this becomes -3x plus 2y equals 12. So there's your new system that you want to solve. And you have several options that you can use. You can choose to get rid of the x's by multiplying the top equation by 3, or you can choose to eliminate the y's and eliminate the fraction at the same time. What would you multiply 1/2 by in order to get 2? Well, if you multiply by 4 in the numerator in this first equation, then you will get a -2y here, which will eliminate when you add with the positive 2y. So that could be one way to go, is multiply through by 4 in the top, and that eliminates both the fraction and the variable. So when I do that multiplication, I'm going to get 4x minus 2y equals -16. Bring down the second equation. I did not do any alterations with that. And now use addition. The y's will eliminate. 4x minus 3x is x. And -16 plus 12 is -4. I need the y value, so choose any of the equations. I'm going to choose this equation, so I'm going to substitute in the -4. So -3 times -4 plus 2y equals 12. -3 times -4 is positive 12. Subtract 12 from both sides and you get 2y equals 0. Divide by 2 and the y value is 0. Remember that 0 is a perfectly valid answer. It's not a no solution or all real numbers, it's just 0. So write your answer as a coordinate point, the x first, -4, 0. Alright, the next 4 problems have the instructions to solve each system using any method. Show all work for that method, which means you can choose whatever method you prefer. That means substitution, elimination, or graphing. Typically, I only use the algebraic method, so I will only be showing either substitution or elimination. For this particular problem, you could use substitution. If I chose to solve this bottom equation for x, I would add y to both sides. So I get x equals y plus 1. And now I'm going to substitute that in for the x in the top equation. So that would be 5 times y plus 1 minus 2y equals 8. Do the distribution, so you get 5y plus 5 minus 2y equals 8. Collect your like terms. 3y plus 5 equals 8. Subtract 5. 3y equals 3. And divide by 3. Y is equal to 1. Substitute that. I would plug it back here, but you could plug it in anywhere you prefer. X equals 1 plus 1, so x equals 2. Write your answer in coordinate point form. Number 11, the directions are still to solve using any method. This one is set up nicely to use addition because the y's are already opposite coefficients. So they will eliminate, getting 2x equals 0. Divide by 2, and x is 0. And then substitute. I'll choose the top equation. 0 plus y equals 5. Well, 0 plus y is just y, so y is 5. Write your answer in coordinate point form. All right, moving on to number 12. Number 12 is set up nicely to use the elimination technique of subtraction because the coefficients of the y variable are the same. So I'm going to change all of the values to the opposites of the second equation. So the 2x becomes positive, the y becomes negative, and the 6 becomes negative. Now I'm going to use addition. The y's will eliminate. I get 5x equals 0. Divide by 5 and x equals 0. I want to replace that into either equation. I'll use the top equation. So 3 times 0 plus y equals 6. Well, 3 times 0 is just 0. And 0 plus y, of course, is just y. So the answer here is 0, 6. Okay, this next one that we're going to solve using any method, once again you could choose to use elimination or you could choose to use substitution. I'm going to use elimination, and I'm going to choose to get rid of the x's by multiplying the top by negative 2. So when I do that multiplication, I get negative 4x plus 2y equals negative 10. I didn't do anything to the bottom equation, so I'll just bring it down. And now I will use addition. My x's do indeed eliminate, but so do the y's, which means what's left here is just 0. And then negative 10 plus 10 is also 0. Remember that when both variables eliminate, you have one of the two special cases. This is either no solution or infinitely many solutions. Because the remaining statement is true, 0 does indeed equal 0, this is infinitely many solutions.